Hello guys, my name is Joel and I'm going to continue my discussion on ASA. Today we are going to look into something called as a transparent firewall. Alright, so transparent firewall is basically the layer 2 L2 implementation of the ASA, I would call it as. And why do we actually need this, right? So in my earlier videos you would have seen I have used ASA like a layer 3 device, which means every of this interface of the ASA was on different subnets, right? Probably there was like 10.1 network and there was 192 network down or something like that, right? So we had different IP address subnets on either of the interfaces of the ASA, right? The inside interface and the outside interface specifically. But you see in this particular topology here, you see that I have the same subnet on either of them, right? It is 192.1.10.0 on either of the side, that's inside and the outside of the network of the ASA, right? So in such a scenario, right, where you have a single subnet but you still want the capabilities or the features of the ASA, mainly the access control and so on, how would you achieve this, right? So but for doing that you need to use the ASA as a layer 2 device, and that's why we call it as a transparent. And that's this implementation is what we call as the transparent firewall. All right, great. So how do we achieve this? So we achieve this by making two separate VLANs, because we know that in one particular VLAN, if you have one single VLAN, we end up having one broadcast domain, right? And that is not useful for us, because imagine the network here. So this is the inside network and this is the outside network. And on the outside network, imagine we have the clients, right? So we have the clients R3 and R4, and imagine we have the servers on connected to this, or for now just assume that R1 and R2 are my servers, right? And you wouldn't want all the broadcast traffic of the clients to reach servers at the same time, all the broadcast traffic of servers to reach clients, right? Because you wouldn't want that because of the security issues. So that's why we need to have two separate broadcast domains, so that whatever happens in the inside the servers, the domain over here, the broadcast, whatever happens here remains over here, and similarly whatever happens in the client side remains there, right? So that's why we are going to use two separate VLANs, right? Still keeping the same subnet, right? But we are going to define these two ports belonging to one particular VLAN, which will be VLAN 20, and the bottom one would be the VLAN 10. And I also need to mention that one of the interface, which is the outside interface for my ASA firewall, will be in again the VLAN 20, right? So one of the interface will be in VLAN 20, and the bottom interface, which is the inside interface, will be in VLAN 10, right? So this is how we are going to configure. Now why did we put these interfaces inside the VLAN? So I will explain that. So let me um, you know tell you how the packet or how the data actually flows through, right? So imagine R3 is my client. R3 wants to talk to R1, which is a server. So as soon as so R3 basically sends a broadcast, right? Now when the broadcast is sent, it basically reaches, the first to reach is basically my switch port here, which is Ethernet 0/3, and my switch immediately creates an entry in the MAC table saying that to reach R3 I need to go to port number 03, right? And then because it is a broadcast, it reaches all the ports on the same VLAN. So it will reach 0/3, 1/0, and 1/2 as well, which is the outside interface of my ASA. So once it reaches the outside interface of my ASA, because it is a ARP entry, by implicit, the ASA forwards that particular ARP entry on the outgoing interface or the outside interface as well, which is 0/0, right? So now the switch, right, again gets the same packet which you know which it had already received earlier. So the switch basically relearns the MAC of R3 again, but on a different port, right? Earlier it learned on 0/3, now it is going to learn the same thing on which port? 1/1, right? Ethernet 1/1, because it is coming in this way, right? So basically for the same MAC address there are going to be two entries now in the MAC table, one concerning VLAN 20 and the other one VLAN 10, right? And so that's how it reaches VLAN 10. Now when the server responds, right, let's say R1 responds, the packet first reaches 0/1, right? Now once the packet reaches 0/1, what happens? The switch basically learns the MAC address of my server as well on this port, so it updates the MAC table, and the same process happens. Now the packet is also sent to this interface, which is 1/1, right, because because it is in the same VLAN, right, and the firewall basically forwards that on the other interface, right, and once it does that, because it's an ARP entry, right, and both of these interfaces are going to be part of the same bridge domain, right, they're in the same IP subnet, so it's going to forward. Now once it comes over here, the switch will relearn the MAC address of my server on the other interface, which is Ethernet 1/2, this interface, right. Now again, just like earlier, we are going to have two entries for the same MAC address, right, of the server. We are going to have two entries in the MAC table, one concerning VLAN 10 and the other concerning VLAN 20. Great. So that's how the packet flows, right. So next time R3 has to talk to R1, right, if it has to talk to the MAC address of R1, it will directly reach out to, it will forward its packet to the outside interface of my ASA, because it has learned that, right. Similarly, if this guy R1 wants to talk to R3, it will directly reach out to the interface of the firewall. So every single traffic, any traffic, we are basically forwarding it through the ASA. So that's how actually the functionality works, right, underlying. Now how do we do a demo of this quickly, right? So how do we do this? So let's start by what do we do first? Let's start by configuring my switches. I think that will be good, right? So what do we have to do on the switches? So we just need to create two VLANs, and we need to put this interface 0/3, 1/0, and 1/2, right, these three interfaces in VLAN 20, and the other three interfaces 0/1, 0/2, 1/1 on basically my VLAN 10, right. So that's what we have to do. So let's do that, right. So let me pull that out here. I think I already have kept the configurations ready so that we don't waste time on that, right. So let me mention this as the switch. Great. So let me explain. So I'm doing like I said earlier, right, so I'm gonna have my VLAN 10, right. So VLAN 10 basically is VLAN 10 over here, and it needs to have 0/1, 0/2, and 1/1, right. 0/1, 0/2, and 1/1, all of them are going to be in the same VLAN, which is VLAN 10, right. The other three interfaces, which are 0/3, 1/0, and 1/2, right, these three are going to be in VLAN 20, right. Agreed. So let me quickly put this onto my switch, which is over here, right. Let's go inside the configuration mode. Let me probably clear this a bit. Great. Okay, did not get copied, my bad. Yeah, so it got copied now. Let me put it. Yeah, that's done. So if I do show VLAN, sorry. Yeah, so when I do show VLAN, I basically get my VLAN 10 and 20 with the corresponding interfaces, which I've already configured. So this is done. So the configuration on the switch is done. Next is we are going to do the configuration on my routers, right. So what do you have to do on the routers? So I'm going to show that. So we'll start with one of the router, and it's going to be the same for the rest of the routers as well. So let's start with router 1. So what do we do? We'll start with the no IP domain lookup. It's a standard configuration, and not explain that. We're going to do some logging as well. Let's turn on probably the logging on console 0, right, and let's probably put a host name, right. We can do that, right. That's good. Now the interface, right. So the interface IP address is important. So I'm on my R1. I need to configure an IP address on my Ethernet 0/0, right. I'm going to use the same subnet everywhere. So it's going to be 192.1.10.1, right. So that's what happens here, 192.1.10.1. So that's the IP address. Next is my I'm also going to put a loopback address, right. Let's put loopback address 10.1.1.1. okay. The next is we also will enable RIP, right. We are going to enable the routing protocol on my R1. In fact, I'm going to enable routing protocols on all of them, right. I'm going to put RIP this time, right. Version 2, no auto summary, and the two networks is 192.1.10.0 and 10.10.0, right. All of the networks are advertised. Okay, and the last part is I have to enable telnet, right? VTY 0 to 4, password Cisco, probably let's put transport input as telnet, right? So that's what I do that, and there you go, we have the configuration done on R1. So we need to do the same thing on R2, R3 and R4, right, with the slight changes. So let me do that as well. So let me paste this. Let's take R2. So what changes on R2? R2 over here, the IP address will be 10.2 and the loopback is going to be 10.2.2 and the rest is everything going to be same, right? So let me do the same thing for R3, right? So it's going to be R3 and here as well 10.3, right? Here as well 10.3 and rest is all good. The last one is, let's do 10.4 here, right? 4 and 4. Yep, good, everything is good. Yeah, so that was basically my configuration on the routers. Sweet. And let's actually put this configuration on the routers, right? Let's put this on R1. Let's do that. Let's go to R1. Let's do that. There we go. Let's do the next thing on R2. Okay. That's done. Let's do the next thing on R3. The last one is, okay, need to put in a enter. Did I do that here? Yeah. Great. So the last one is R4, right? Okay, this is 4. Done. Right? So we have done all the configuration on my routers. The only configuration remaining is on my ASA, right? So on my ASA, what do I do? That's just interesting. So on my ASA, let's go down here and let's start the configuration. Yeah. So the first thing is we need to make it into a layer 2 device. So that is done by the command firewall transparent, right? The whole topic what we are talking to today is transparent firewall, right? So once you do this, all the layer 3 capability is gone, right? Everything is all the layer 3, so you can't even run show route command. I mean, yeah, right? So you won't have anything inside that. So that's my command which makes it layer 2, right? Now it's pretty simple. What do I have to do? The two interfaces, right? One of them is 0/0, which is my inside interface, and 0/1, which is my outside interface. So let's do the inside interface. 0/0, I need to put the name if as inside, security level is 100. Now this is interesting, bridge group, right? This is probably the first time we have used this particular command, right? Bridge group. So this command, the bridge group 5, right, it should be the same on both the interfaces, right? So it basically tells the firewall that both are part of the same IP subnet or the same broadcast or the bridge domain, right? So now any ARP that basically goes inside 0/0, basically it would, so let me put on the other interface as well. So the other interface is basically the outside interface like this. So that obviously has a security level 0, and my bridge group is going to be 5 over there, right? So it's going to be the same, right? So it basically tells the firewall that whatever packet, ARP packet that goes inside one of the interface, right, it has to or will be sent to the other interface as well, and it's going to be vice versa from here to here and here to here, right? So that's why we need to do that. So that's step 2, and the third step is basically creating a virtual interface, bridge virtual, right? So BVI, I think you would have heard of BVI before. So we need to create a BVI over here, right? And we are going to give it an IP address, right? So it basically, you can imagine the whole thing has been condensed, right? The whole device has been condensed into a layer 2, and we have basically given it that IP, right? And that IP is basically 192.1.10.10, right? So yeah, so I think that's basically the configuration which would go in, right? I think we are ready to test it now. It should be good, right? So what we are going to do is what we did just now. We just set it up. Okay, we probably did not put this configuration on the ASA. Let me put it up. So that would go down on ASA over here, right? Let's put that here. Paste. Oh, my bad. Sorry, I did not put a config command. It's bad. So let's put config t. Great. So yeah, so that was basically the configuration on my ASA. Sweet. Now we gotta test it. So let's go on to my R1 and see if we can. Let's clear the screen a bit, right? So what do we do here? Okay. So we need to for testing. Let's ping probably my R4, right? So let's do a telnet, not ping. Sorry, let's do a telnet from R1. Right. If this is the inside interface, obviously it has to go, and let's do a telnet to my R4, right? The basic fundamentals of ASA is still valid, right? The inside and outside, right? The traffic would basically flow from high to low. 192.1.10.4 if I'm not wrong. Yeah, there you go, it works. And right, I'm inside now just R1, and I can do a show users, and I basically get that. There is a telnet, right? And yeah, I think that should work. I think I have put host name as R1 on everything. Did I do that by mistake? Yeah, I have put host name as R1 on my R4, so I think that's why it was showing. So let me change that quickly. So this is actually supposed to be R4, right? Did I do that here as well? No, this is R3, this is R2, and that's R1. So yeah, now if I exit and do this again, so you can see there is R4 here, right? So that was basically one part of this which I wanted to show you. Let's continue with the next part now. What do we do next? Let's put two conditions, right? So what we did now was we did a telnet from the inside of the network to outside. We did it from R1 to R3, which is awesome. But what if, say, we have the clients here and you want to give them access to your servers? You want R3 to talk to R1 and R4 to talk to R2, right? Let me actually write it down here so that we remember, or maybe I can write it down here as well, right? So what we gotta do here is we want R3, right? We want this R3 to uh, be able to do telnet or say HTTP, right, to say R1, right? And the other one is we also want R4, which is my, so my R3 and R4 are on the outside, right? So normally, they would not be able to do. So if I go down to R3 and if I do a telnet to R1, it won't work because this is the outside interface of the firewall and this is the inside interface, and traffic doesn't by default flow from outside to inside, because it has a low security level when compared to inside. So obviously we need to do this using ACLs, right? Access policies. So let's say R4 also needs to do telnet and probably let's say ICMP, right, to R2 though. Great. Okay, this looks good. So how do we achieve these 2 points, right? Obviously using access list. So what I mean to say is once I have achieved this, it is going to function like a normal ASA. Whatever I used to do in my normal ASA, I'll be able to do that. So I wanted to show you guys that, right? So let's put those access policies like what we have done in the previous videos, if I'm not wrong, right? So for R3, what would be the access policy? So we're going to put this one, access list outside TCP. The host is from R3 and it has to access R1 and the port is 23 because it is telnet. We're going to do the same thing but with a different port for HTTP, which is 80, right? Agree? Right? That looks good. Next, what do we do next? let's achieve the same thing for my for the other condition as well. So let's just take this up from here, let's put it here, 10.4, right, and we need to reach 10.2 here, and the port is 23. Okay, and the other one is basically we need to allow ICMP, which is basically ping, right, from R4 to R2, R4 to R2 and ICMP. Great. So these are my access list. And the last part is we need to have access group as well, right, because just having access list is not sufficient. You need to apply it on the interface. So we're going to apply that on the interface, and the interface is basically going to be outside, right? So because what we are trying to do is we are trying to allow we are trying to allow the outside clients to access my inside servers. So this is the interface, and the direction should be inwards, right? So that is why the direction is inside, the interface is outside over here. So once I do this, we will be able to do the conditions, or we'll be able to follow those conditions. Let me do that first. Let me put this on the interface. I'm putting this on the ASA, right? So I have to this thing, and I've put that as well. Great. Okay, so that looks good. Let me clear the screen and show you guys how the access list actually looks. So access list, okay, all the 4 access list, all the 4 lines in the access list has been put. And now I will be able to actually ping from my outside interface to inside. I will be able to telnet to start with, right? So let's see that. Clear screen, right? So probably let's end this. So what will I be able to do? I will be able to do telnet from R3 to R1, but I will not be able to do telnet from R3 to R2, right? So let's try this first. Telnet from R3 to R2. Let's try from R3 to R2. It should not work, right? Because the ACL has not been deployed to do that, right? Let's see if this should time out basically, right? It timed out. Now let's change the 2 to 1 and see if it works. There you go, it worked, right? Okay, password is Cisco. Yeah, it worked. We are inside R1 now. Okay, so that's what I wanted to show you guys. I can also show it to you from R4. From R4 I have enabled ping, right, towards R2. So that should work as well. Let's clear the screen. So if I do a ping towards 192.1.10, probably .1, no, sorry, it should work towards .2, right, because R2. There you go, it worked. So that was basically the piece which I wanted to show here, which is which basically tells that at this point you will be able to control access exactly the same way you did in a normal L3 firewall, right? High to low is basically allowed by default, and from low to high you need to use ACLs. Okay, now the next part what I wanted to show you guys here is routing, right? So in my earlier video I think I showed you where we used routing 3 different routing protocols for 3 different regions, inside, outside, and the DMZ, right? But now that they all have the same broadcast domain, they have the same subnet, I can use just like one routing protocol, and it should work, right? But the problem here is that let's take RIP, right? And I have enabled RIP on all my 4 routers, right? But still, if I go down to my let's say R3, let's go down to R3 and see show IP route, right? You will not see the routes for R1 and R2, right? You don't have that. You have just 10.3, but you don't have 10.1 and 10.2. And why is that? The reason is because the RIP, let's take RIP, right, because we're using RIP here. RIP basically uses UDP port 520, and it's a multicast kind of a multicast packets are exchanged between the routers for the broadcast of the network. Basically the network updates are nothing but multicast packets, and firewall by default doesn't allow the multicast packets to go either way. So we have to enable it explicitly by using ACLs again, right? So that's why R3 doesn't have the route. So we need to explicitly use ACLs for doing this. Okay, so so we need to do it in both the directions. Now when you're doing it from inside to outside, right, from inside to outside you can basically permit all the packets, so the configuration is going to be pretty simple, right? Inside to outside is basically high to low, right? So it's going to be this. Let me do that here. Let me go and write this as routing, right? And here There you go. So from high to low, basically, if you want to enable the routing updates from inside to outside, it's going to be pretty easy. You can just you can create an access list, permit, and you can do any, because you know uh, it won't harm the network, right? From inside to outside, you're trying to access anything, it won't harm the network. So I'm going to do IP any, and then going to put it on the interface inside, and the direction is going to be inwards because we are talking about the packets going towards the ASA, right, inside. Now this won't be the same while we do it from low to high, right, from low security level to high security level, because we don't want to do any. If you do any, then all the packets would basically enter, and we don't want that, right? So we do low to high. So for RIP we need to explicitly enable the access, or for that particular multicast address, and that's going to be, so this is the permit. It's a UDP protocol, it uses UDP, and I'm basically telling any host, right, and the destination is basically 224 009. So if there is a packet with the multicast destination address being this one, then it clearly means that it's a RIP packet and it has to be permitted, right? So I'm basically putting this, and this would basically achieve my routing, right? Now let me put these two lines first on my on my ASA. Great. Now I need to put this line as well, but I need not go and enable this on the interface because I already have access group outside on the interface. So as soon as I put this, it would get enabled, right? So I need not use access group again, right? So let's do that. There you go, we have done this. Now let me go and refresh my R3, check the routes, right? So you can see the difference now. Earlier there were just 10.3 and 10.4. Now you can see 10.2 as well, right? You can see this route, right? And now the 10.1 was missing earlier, but now I refreshed it and I have got 10.1 as well. So 10.1, 10.2 are also present, which means R3 has the routes for R1, R2, and similar is the case for R4 and the other routers as well. So that was basically all right. So that was let me like clear the screen here a bit. Okay, so that was routing. That was basically the routing part. Now what do we do next? The last part which I want to cover here is the ether type, right? Ether type of ACL. So different kinds of ACLs called as ether type of ACLs. Now to explain this, I think I have to talk to you about the OSI model, right? The OSI layer, I think the which we have probably studied way back in our college, right? Well, I'm not that old, so it was like just few years ago. Anyway, so the OSI layer, if you look at the OSI model, how does it work, right? So how does the transport layer know which application it has to deliver its packet to, right? It basically uses the port numbers. Similarly, if you go one level down, how does the network layer decide which transport layer it has to talk to, right? And that is again decided by something called as a protocol number, right? For TCP it is 6, for UDP it is 17. And one step down you see the data link layer, and if you want to decide which which piece in the network layer or which protocol in the network layer the data link layer wants to talk to, now that is the place where ether type comes into play, right? So ether type is again just like the protocol number. There is like certain numbers. For IP it is you have like a particular number, for MPLS you have a different number, and depending on what is present in the packet, that particular protocol of the network layer is going to be worked upon, right? So that particular layer of the that particular protocol of the network layer will be used, right? So network layer protocols, I think we are pretty familiar. We have like IP, and IP is very predominant now, but before we used to have something like IPX, Apple Talk, and so on, right? And we also have like a 2.5 layer like MPLS as well now, right? So the whole conversation here, or the whole discussion is, what if the firewall ASA by default just recognizes the IP, right? By default the ether type is IP for ASA, But what if you have some kind of MPLS routing going on around here, and you want the ASA to understand that, right? For the routing to for the packets to flow freely around, you need to enable this again by using access list. So that is where your Ethertype ACLs comes into picture, right? So let me put that part here. It's Ethertype right here. Great. So I'm going to put the commands are going to be pretty simple here. Again, let me just explain one of it. So it's going to be access list. Going to put a name for access list ABC. You need to use the word ether type permit, and this is basically the number which is associated with the ether type. So what I've mentioned here is for multicast unicast, sorry, for MPLS unicast, my bad. Similarly, if you have some custom applications running, you can use those numbers. I'm just putting some random numbers now, like 2111. Probably I can use another number as well, probably like sorry, 6137 as well, right? Pretty good. And obviously I need to enable this on both the sides, on both the interface. So I'm going to enable it on my outside interface and inside interface as well. On the outside interface, again, it's going to be towards the ASA, so it's the in direction, and the inside as well is going to be towards the ASA, so the direction is going to be inwards, right? So you can see this. So I can take this up and put it down on my ASA, and that'll be the end of it, right? There you go. So obviously I won't be able to test this now because I don't have an MPLS network, but if I can show you here, show access list, you can look that it basically tells that this is for MPLS unicast, right? And these are a couple of custom protocols which I'm going to use in case I have custom applications running of that sort, right? So that was basically all the discussion around layer 2 ASA, I would say, like transparent firewall is what we call it. And hope you liked it. Tune in for more videos coming soon, right? Thank you.